Hello, geometry kiddos. Yesterday we did a lesson on 3-5, and today we're going to continue on with 3-5, which is writing equations of parallel and perpendicular lines. So we're going to run through 3 sample problems today and then do homework that is on lesson 3-5. All right, we already did that first sample problem yesterday. So today we are going to do the second problem. So right now I'd like you to stop the video, pause it, and then go ahead and see if you can find where P is going to be so that it is between A and B in the ratio of 3:7. So go ahead and pause this video and then resume it and give it a start. All right, I am going to start with my x's. I like to do my x's first. So I'm talking about the distance from -2 to 4. So if I go from -2 to 4 on a number line, that is 6 units. Now, if I have AB, A is here, B is here, I'm going to have point P somewhere on here so that if I divide this, 1, 2, 3, 4, 5, 6, I have 3 pieces, 1, 2, 3. So right here, this is where P is going to be, so that I have 3 pieces on one side and 4 pieces on the other side. So P is going to be somewhere between A and B. So I only want to go part of that. I want to go 3/10. So the whole thing is divided up into 10 spaces, 3 on one side, 7 on the other side of P. All right, so when I do 6 times 3/10, I get 1.8. Now, if I'm going to do my y values from 1 to 5, that is 4 units. And again, I'm going to multiply by 3/10. So you could certainly multiply it by 3/10 and write it as a decimal. Either way is fine. And this time I get 1.2. So now I have to go back to A. So start from A, because that's where I did my ratio from. I did 3/10, so I started from A here. So my A is at -2 and 1, and I have to add to it plus the x value 1.8, and I have to add to the y value 1.2. So -2 plus 1.8 is going to give me -0.2, and 1 plus 1 point, this is going to give me 2.2. So this is where P is going to be. And -0.2 is between -2 and 4. And if you look at 2.2, that's between 1 and 5. So that answer does make sense. All right, second problem we're going to do. Write an equation of a line that's parallel for part A and perpendicular part B. This is definitely going to be a test question that you will see. So I'm going to do my parallel line first. So what we do is we have this line that goes like this, and we have a point right here, 3, -1. What I'm going to do first is I'm going to write a line that's parallel to it. So I'm going to write a parallel, y equals blank x plus blank. Well, these two lines, when they're parallel, what do we know about their slopes? Their slopes are the same. So if the slope of that purple line is a -3, then this slope has to also be a -3. Now we're going to use this ordered pair. We know that this point right here is on that line. So the x value is 3 and the y value is -1. So I'm going to plug those numbers in to my equation. And in place of x, I put a 3. And I am going to solve for b. So I have -1 equals -9 plus b. I'm going to add 9 to both sides. And it looks like my y-intercept is going to be 8. So make sure you go back in and fill in your equation. So the answer to the problem is going to be y equals -3x plus 8. Okay, now I'm going to do my perpendicular line. So when I do my perpendicular line, that is going to be this green line. Okay, it still has to go through that same point. So I'm still writing an equation. And now this time the green line perpendicular to that purple line, if that slope is a -3, then the slope I'm going to use for my perpendicular, remember, is the opposite reciprocal. So I'm going to use 1/3. And it's still going through that ordered pair 3, -1. So I'm still plugging in those same numbers for x and y. And I'm going to solve for this y-intercept. So here I'm going to subtract 1 from both sides, and it looks like my y-intercept this time is going to be a -2. So the perpendicular line would be y equals 1/3 x plus a -2, or just a -2. It doesn't matter whichever way you write that. All right, last sample problem for today. We're just going to do this number 6, this problem at the top, where we're finding the distance from a point to a line. So we have a line. This black line here represents the y equals x plus 4. And we have this point right here, 6, 4. So what we are trying to do is find the distance from this point to this. And so in order for it to be the distance, remember that needs to be perpendicular. So in order to find distance, what do I need? To find distance, I need 2 points. Well, I have 1.64. I need another point right here. I need to know what that point is, and once I find that, then I can find the distance using the distance formula. So what I'm going to have to do first is find the equation of that blue line. So I'm going to find the equation of my blue line. Once I know the equation of that blue line, I'll have an equation of the blue line and the black line, and then I can solve my system to find that ordered pair. So the equation of that blue line is going to be y equals blank x plus blank. So what is the slope of that blue line? Well, we know that this line is perpendicular to the black line, and we know that that black line has a slope of 1. So this blue line is going to have a slope of -1. And then we know we have this ordered pair. So in place of y, I can put 4. In place of x, I'm going to put 6. And I'm going to solve for that y-intercept. So 4 equals -6 plus 10. Whoops, plus b. My brain's already adding this 6. And I get 10 for my y-intercept. All right, so now I have the equation of the black line and the blue line. So what I'm going to do now is I'm going to solve a system in order to find the ordered pair, the point that they have in common. So I have the equation y equals x plus 4, and I have the equation y equals minus x plus 10. Now, normally we would maybe put that into standard form so that it was x plus y equals a constant, but everything's lined up here because they're in the same form. And as luck would have it for us, when we add straight down, we get 2y, and our x's are going to cancel out because one's a positive and one's a negative, and they're both 1s. So 4 plus 10 is 14. Divide both sides by 2, and I get my y value to be 7. So I know up here that this y value is 7. So I need to find out x. So I'm going to plug it into this first equation right here. So 7 equals x plus 4. So it looks like my x value is going to be 3. So this point right here is 3, 7. So now I need to find the distance between the 2 points, 3, 7, the one we just found, and the point they already gave us, 6, 4. So we're going to take our two x values, 6 minus 3 quantity squared, plus 4 minus 7 quantity squared. So 6 minus 3, so this is going to be 3 squared. This is negative 3 squared. So I have 9 plus 9. So it looks like I have the square root of 18. Now, typically they're just going to have us round this to the nearest tenth, but if they want an exact answer, so every once in a while the book's going to ask us for an exact answer, and if they're asking for an exact answer, we're going to say that the square root of 18 is the square root of 9 times the square root of 2, so it would be 3 root 2. If they don't ask for an exact answer, then we're going to round to the nearest tenth. So if we take the square root of 18, I believe that is approximately 4.2. All right, so in order to do this problem, we had to first draw in our perpendicular line, find the equation of that perpendicular line, which in this case is the blue one. And when we had the blue line equation and the black line equation, we solved the system to find where those two lines meet, and we got that ordered pair. And once we found that ordered pair, then we could finally find the distance from the point to the line. All right, good luck on the rest of your lesson 3-5.